Hi there, welcome to The Guide. I'm so glad to have you here, and I'm excited to share this information with you. Let's begin with the beginning. Darkness. Nothingness. In the absence of light, the world disappears. As visual artists, light is the origin of our magic. It brings the world into visual existence. You may think of yourself as an oil painter or a digital artist, but your medium, your real language, is light. You create images with light effects, the way a conductor brings music alive with instruments. In this guide, we will explore together the structure of this visual music. Here is what's on the menu. We will begin with the foundations. That means what light is, how light works, and how to separate light from shadow. Next, you will learn to create realism by understanding 12 different light effects. The third topic is inventing light. Here you will receive a powerful tool. It will serve you when you're working from imagination and also when you're working from life, from observation. We will finish the lesson with the master key to unlock these 3 domains. I hope that sounds like a worthwhile adventure. Let's dive in. Do you know what light is? I think we all know superficially, but nobody really knows, nobody fully understands what light is and why light exists. But we have a few ways of describing light that are useful for us as image makers. Light is energy. To be specific, it is electromagnetic energy. We won't really go into physics here, but this is the same type of energy as gamma rays, X-rays, microwaves, and radio waves. What we call light happens to be the particular range of electromagnetic energy that our eyes and brain evolved to perceive as brightness and color. For our purposes, we will think of light as light rays. A light ray originates from a source. It then travels in a straight line, and when it hits a surface, it is reflected. This is how light creates the world around you. When you draw a portrait, you might think that you're drawing an eye or a nose. But what you're actually doing is drawing the effect of light on these forms that we call noses and eyes. So there's a reason behind everything you see on the model. And these reasons can be understood. That's precisely what this guide is about. The fundamental distinction we make at the beginning is the distinction between light and shadow. You can think of this as 2 countries, the country of light and the country of shadow. I realize this sounds like the beginning of a bad fantasy novel, but please bear with me. There's a border separating these 2 countries. Unfortunately, there are many different names people use for this border. Some call it shadow line or shadow edge, some call it bedbug line, and some even call it core shadow, which is a good approximation, but not quite accurate. I personally really like the word terminator. This is what astronomers call the dividing line on a planet between the dark side and the illuminated side. I like the word terminator because it reminds me that the light terminates at some point on the surface. Let me show you what I mean. Let's move the camera so that we can see what the light can see. you might notice that there's no shadow on this head right now. That's because what the light sees is, by definition, illuminated. It is in light. We are now looking at the lit side of this head. If we leave the light at the same position, but move the camera a little bit to the side, we can see the shadow again. This means that the terminator marks the boundary of the area that the light sees. What the light can't see is what falls into shadow. For any given light source, there is no ambiguity. Either something is in light or it's in shadow. Let's look at this drawing again. I don't know if you like this drawing or not, but I hope you agree that the sense of light and the sense of form are working fairly well. This is because I chose to pay close attention to finding the terminator and maintaining a clear separation between light and shadow. Once this first step was achieved, I was able to systematically take the drawing further by using more advanced light effects. Are you ready to learn how to do this? Well, boys and girls, tighten your seatbelts because we're about to go deep. May I introduce to you the sphere. It will help us to create realism by understanding light effects. Since we were just talking about the terminator, can you find it on the sphere? It's right here, separating light and shadow. The part of an object that is in light is called form light, whereas the part of an object that's in shadow is called form shadow. It's very useful to distinguish between the form shadow and the cast shadow. The form shadow is part of the object you're drawing, but the cast shadow is the result of a projection. Light is hitting the sphere and projecting the cast shadow onto the floor. By the way, did you know that the shape of the cast shadow is created by the shape of the terminator line? That's pretty cool and pretty nerdy, but you came here to learn, so I'm giving you everything I know. Alright, these are the 4 basic light effects that allow us to separate light and shadow. There's form light and form shadow, and there's the terminator, which separates the two and projects the cast shadow. You can do a lot with these 4, and it's important that you understand them. So let's put this into practice. We're going to draw a few eggs. If you're intimidated, you can relax. It's going to be very simple and it will take less than 2 minutes. You can absolutely do this. You need 2 things, a piece of paper and a pencil. Any paper is okay. If you have an eraser, you can add it, but it's not necessary. Press pause now and get a pencil and a piece of paper. Wait, are you still just sitting there? Maybe you have to trick yourself into drawing. Maybe you won't draw just yet, but you can at least get a pencil, right? Do it now. All right, wonderful. I will draw a few ovals on this sheet of paper. You can follow along. Keep your hand relaxed and try to draw each oval in a soft, continuous movement. Do maybe 4 or 5. Then let's divide each of these eggs into light and shadow by drawing a terminator ellipse. Again, stay soft and relaxed. Don't worry about where the terminator goes exactly. We will take a look at that the next time we draw. Alright, now we tone in half of each egg with shadow. Pick one half, it doesn't matter which one. As I said, this is simple. Don't underestimate the power of simplicity. Understand that you build strong foundations from mastering simple skills. Alright, now to finish it up, let's draw cast shadows. Just estimate where they go for now. There's no need to construct them. Estimating roughly the light direction, drawing a cast shadow, and then filling in the cast shadow. That's it! Here's our first page of simple eggs separating light and shadow with form light, form shadow, the terminator, and cast shadow. If you want, you can do a few more drawings of objects on a table in front of you. Focus on finding the terminator and separating light and shadow. Now, to create realism, let's take the next step. Separating light and shadow allows you to make your drawings understandable to your audience. But we can do so much more. We can create volume, suggest different materials, and play with more subtle light effects. To do this, we use modeling factors. Modeling factors are predictable light effects. If your goal is realism, you can think of modeling factors as your tools for achieving that realism. You can also use them as a checklist. If one or more of these modeling factors are missing, your image probably looks less real than what is possible with all of the modeling factors. We're going to look at 12 of them. The first 4 allow us to separate light and shadow, and you know them already. The remaining 8 help us to create realism. The first of these 8 modeling factors is reflected light. It's also sometimes called bounce light or indirect light. In this scene, the light is coming from above. It hits the floor and reflects back into the form shadow of the sphere. One important thing about reflected light is that you can find it only within the shadows. That means form shadow and cast shadow, but almost never within the form light. If you take a closer look at the form shadow, you might notice how the reflected light gets darker or weaker the higher we go on the sphere. This happens for 2 reasons. The first is that light loses energy the further it has to travel. The second reason why reflected light gets darker is that the surface of the sphere is rotating away from the floor, which is the source of reflected light, and this weakens the influence of reflected light. Now, put your attention on the area where the reflected light is fading out. There's a name for this area. It's called the core shadow. I said at the beginning of the video that many people confuse the terminator with the core shadow. Can you see why? They're kind of in the same area. But the terminator is where form light meets form shadow. The core shadow is created by the reflected light. If there is no reflected light, there is no core shadow. A great example of this is the moon. You can clearly see the terminator, but there's no core shadow. That's because there is simply nothing to reflect light back into the form shadow of the moon. So the dark side of the moon just blends into the blackness of outer space. The next modeling factor is the penumbra, which is the softness around the cast shadow. The softness varies depending on the distance to the object that creates the cast shadow. The closer the cast shadow is to the object, the sharper the penumbra. The further away the cast shadow is from the object, the softer the penumbra. If we replace the sphere with a stick, you can see this effect a bit more clearly. Next, the halftones. Halftones are the changes in tonal value within the form light. As a surface gradually rolls away from the light direction, the angle of the light gets more and more shallow. As a result, the surface gets darker and darker until we hit the terminator. Can you see where the lightest halftones are? At the top right? Some art books label this area the highlight. I think this is inaccurate. The highlight is not a halftone. The highlight is a reflection of the light source itself. The more shiny, oily, or reflective a surface is, the sharper and brighter the highlight. A more accurate term for the highlight is specular reflection. Specular comes from the Latin word speculum, which means mirror, so it's a mirror-like reflection. It's very important that in your mind you separate the highlight from the halftones. Halftones model the form, they turn the form, while the highlight sits on top of the halftones, and it's usually the lightest value used in shading. Alright, I need your full attention now. There is a useful name to describe the general region of the lightest halftones. It's called center light. This is the area where the surface of an object points most directly towards the light source. Because of this, it contains the lightest halftones, but it's not the same as the highlight. Let's rotate the camera. As I do, watch the highlight move, but the center light stay in place. Got it? Not many people understand this one, so you're becoming an expert. When you're shading something, identify both the center light and the highlight. By the way, on matte surfaces, there might only be a center light and no highlight. The two final modeling factors are ambient light and ambient occlusion. You can think of ambient light as the general brightening effect that the sun or another powerful light source has in a scene. For example, in an interior, the ambient light is natural light coming in through the windows and reflecting off of the walls, the ceiling, and the floor in the room. It's important to distinguish ambient light from direct light, such as the spots of light that you can see on the wall and on the floor. This is light that comes directly from the light source, travels through space, and impacts a surface. It's much more powerful than ambient light. Ambient light is indirect light. It often has a general direction, but it is softly scattered throughout the scene. Ambient light has two main effects, and they both influence the shadows. Ambient light softens and lightens shadows. In the painting on the left, the shadows are very dark because there's almost no ambient light. The walls are dark and the light is very contained. On the right, it's difficult to see the shadow shapes, but they are there. They're just very light and very soft. So there's a direct correlation between the intensity of ambient light and the value and sharpness of the shadows. Again, there's a direct correlation between the intensity of ambient light and the value and sharpness of the shadows. A common way to control ambient light is to build a shadow box. It prevents ambient light and other light sources from reaching the subject. So here we have a very low amount of ambient light and clean, dark shadows. The exact opposite is a light tent, which is often used in product photography. This is maximizing ambient light, and there's basically no shadow left, except for cavities and where the object touches the floor. With ambient light comes its opposite effect, ambient occlusion. This is a very important modeling factor if you want to create more realistic images. Occlusion means hiding or blocking. Ambient occlusion is a type of shadow that is created when ambient light is blocked from reaching a surface. Out of all the modeling factors, this might be the most difficult to understand. On your left, there's a regular 3D render using all the modeling factors. On your right, there is just ambient occlusion shadows. This is the beauty of 3D programs. I can tell the computer to just calculate one modeling factor. In this case, ambient occlusion. As you can see, we have a ball with a little shield in front of it. Watch the image on the right. I'm going to pull this shield back away from the ball. Can you see the occlusion shadow? Can you find it also in the left image? It might look subtle, but that is because we're so used to seeing reality, well, looking real. Watch this. I'm going to remove the occlusion shadow. Ready? See how wrong that looks? This is what happens when you forget to draw ambient occlusion, or when you don't know about it. But now you know about it, so you just need to remember. Let's bring the occlusion shadow back. So much better. This is a powerful modeling factor. Alright, look at the right image. Let's pull the shield further away. Did you see how much softer it got? This is the principle. The closer two surfaces are to each other, the darker and sharper the occlusion shadow. The further away two surfaces are from each other, the lighter and softer the occlusion shadow. I would like to make you aware of one more thing. Ambient occlusion shadows are only really visible in the country of shadow, or the shadow family, and almost never in the country of light, or the light family. This gives you a shortcut. When drawing ambient occlusion, you only need to look for it in the form shadow and cast shadow. Take a look at the floor in the right image. There's occlusion shadow all around the sphere. It gets darker as the sphere and the floor are getting closer to each other. In the left image, there is no occlusion shadow on the left side, where we have direct light hitting the floor. This is because direct light is so much more powerful than occlusion shadows. If you look very carefully inside the cast shadow on the floor, you can see ambient occlusion there. Here's another before and after example. It's an egg with a form light, form shadow, and cast shadow. And here it is with ambient occlusion. To break it down, there's occlusion in the form shadow and in the cast shadow. And this makes all the difference between something flat and graphic and something much more real. I'm really happy to be sharing this with you. Ambient occlusion is one of the things I would like you to take with you from this course, because it is everywhere. Once you know how to look for it, you'll see it, and you'll put it into your work, and your work will be stronger. It took me a while to really understand the concept of ambient occlusion, but when I did, this idea really changed the way I drew. So if this is new and you don't quite understand it yet, be patient with yourself. Maybe listen to this explanation again and do your own research. So, we have them all. Let's review the 12 modeling factors. The first 4 help us to separate light and shadow. They are form light, form shadow, the terminator, separating the two, and projecting the cast shadow onto the floor. The remaining 8 modeling factors allow us to actually create form and realism. Inside the form shadow, there's the reflected light, which also creates the core shadow. There's the penumbra around the cast shadow. Then inside the form light, there are halftones, which create the turning of the form, the highlight, which is the reflection of the light source, the center light, which is where the lightest halftones are, where the form is pointing towards the light source. And then throughout the scene, there's ambient light and ambient occlusion, which regulate how light or dark the shadows are. Let's do some hunting together. Can you find form light and form shadow? How about cast shadows? Okay, this is pretty easy. Now, how about occlusion shadows? The most noticeable example for me is probably here in the cast shadow of the sphere. The deeper we go into that shadow cave, the darker the occlusion shadows get. Also, on that sphere, there's a beautiful reflected light. It brings out the core shadow really well also. And notice that core shadows are much more visible on curved surfaces. You won't find it on the block, but you can see it on the sphere and on the cylinder. Now, can you find a center light area? Nice. And what is the overall intensity of ambient light here? I don't know about you, I would say maybe 15%. It's not an exact science, but it's pretty low and the shadows are quite dark. Cool, well done. This is a portrait painted by my teacher's teacher, Pietro Annigoni, in 1949. I'm not sure if he had names for each of these modeling factors, but he was clearly aware of them in nature. There's a center light up on the forehead. There's reflected light on the chin. Occlusion shadows in the nostril. And here, between the layers of fabric. All these modeling factors conspire to create a rich image. What you have just learned here is changing your perception. It's refining your senses, allowing you to see more. And as you go about your days, keep looking at the world around you and see what you notice. And then you can put the things you notice into your artwork. If you've been watching all this time, now would be a perfect moment to take a break. Pause the video, get up, maybe get a glass of water and stretch. Your brain will absorb the information much better if your body is awake and well hydrated. I'll see you back here in a few minutes.